I guess it's being recorded. So we're going to start on the plumbing, although next Tuesday we'll do 5 and 10. We'll do the review questions on 5, go through chapter 10. If there's anything else by popular request that we need to cover, you just let me know. So we will talk about the plumbing. You'll need your other book for this code check. So this is strictly for residential. I have the, let me, it takes me a minute to get this thing straightened out. The computer reacts very slowly for some reason with this overhead. So what you have, I believe, is the 8th edition. So, and I'll have to find my 8th edition, but there's not that much different in the 7th edition. There's a few things to be aware of, though, when using these other documents. Number one, this is based on the International Plumbing Code as well as the Uniform Plumbing Code. So you have to make sure which one you're looking at. This particular document covers building, plumbing, mechanical, and electrical. And so there's some pictures in here that you may find useful, but this is strictly residential. So we can take. Now, inside the front cover, there's some information here, I think.
Yeah, it says code check on it.
Yeah.
ICC 2015. It's got abbreviations,
So,
nice.
well, the one you have is a little bit newer, but still not much different. So there's a number of codes that are referenced in here. ICC is the, there's an International Residential Code. So the addition here is irrelevant, but basically the state of California adopted the building provisions of the IRC, but they adopted the plumbing provisions from the Uniform Plumbing Code. They adopted the mechanical provisions of the California Mechanical Code from the Uniform Mechanical Code. And we've been working on the National Electric Code, which is what the California Electric Code is based on the National Electric Code, the most recent one. And up here on the right, they talk a little bit, they tell you what those model code organizations are. And there's some other information in here. Now, if, hopefully, as I scroll up, if you're going through the book and you see an abbreviation of some sort, they're all here. So this is inside the front cover. So A, they say is amps, ABS. We will be talking a little bit about it. That's the black plastic pipe that you see for sewer, drain waste and vent. So I guess I should ask you to spell that. Acrylonitrile butadiene styrene plastic pipe. But normally we just call it ABS because that's easier. So AHJ they have in there. When we get into the mechanical code, we may be talking about some of these other ones. CU stands for copper. DFUs, those are drainage fixture units. So when we're sizing plumbing, and we will go through a couple of short exercises in the not too distant future on how to do some sizing. But you can look at all of that. So DWV, drain, waste, and vent, we'll be talking about those things. But if you see them somewhere in here, an abbreviation, you can flip back here if you don't know quite what it is. You know, there's that LFMC, and so that covers the building, plumbing, electrical, and mechanical common terms that you'll find in the book. If we look at the electrical, where is the electrical? Oh, there it is.
The bottom.
Yeah, down there at the bottom. You know, this covers, for residential, this is fine, but we came at it with a little more detail and looked at general National Electric Code things that cover both residential and commercial, whereas this is strictly residential. So upper right corner there, you see the floor plan from a house, not a very nice house, it doesn't appear, but that's those 6 foot and 12 foot distances we were talking about for outlet spacing. And that's measured along the walls, not measured between the outlets if you're turning a corner. Minimum conductor sizes, all of that came from that table 24 that you see there. That's an abbreviated version of table 310, 15, B16. But they just have enough information there to cover residential type installations.
That's the minimum wires one.
Yeah.
Yes, table 26 in our book.
Yeah, okay. So, and I will find my correct version. I can look. Let me take one.
It's all the same.
For some reason, I seem to have 3 7th editions.
It's all the same. That it's just table 26 instead of 24, but all the information's the same, Larry.
Yeah, that particular table has not really changed significantly in quite a while. But anyway, this has some pictures in there. If you flip over, they talk about the inside of, and then they have some pictures.
Yeah, we got those pictures.
Yeah, so this hasn't changed too terribly much, but if you wanted to see a picture of some UF cable, SE cable, liquid tight flex, MC cable, NM cable, they've got at least some little pictures of that stuff there. So we're not going to spend too much more time on that, but if you have any questions, pipe up. I guess that's kind of a pun since we're in the plumbing section.
plumbing.
So we're going to look a little bit at the California Plumbing Code, I believe. But if we look at this particular page, you'll notice up there at the top, general. Right here, general. And if you come over to the right side there, you see they're referencing 12. That's the 2012 IRC. You should have a later one.
15.
15, which is more recent. And then right next to it is 12 UPC. So one is the addition of the International Residential Code, which the state adopted for building provisions, but did not adopt for plumbing. So all of the plumbing provisions for California would be listed under that UPC. And so you see that beginning here, we're at 313. That's because Chapter 3 of the Uniform Plumbing Code is where all of the general plumbing provisions are. And we'll take a quick look at that. So you might just want to put yourself a little note that the IRC provisions, which are generally more lenient in the IRC than the UPC, generally are not enforced in California. Some places adopt the IRC in total, but California just adopted the building provisions. And
So California only uses the UPC code?
that is correct. We use the building provisions of the International Residential Code, but they did not adopt the plumbing, mechanical, or electrical provisions in the International Residential Code.
Wow.
So if you're using this particular document, I've seen people get in trouble because they were taking whichever one worked best for them, and that got them in trouble with the building department. And you'll notice some minor changes. If you look in that upper right corner there, for example, you know, for electrical, our clearance only needs to be what? From the edge of a step. Yeah, 1.25 inches. And here,
1.5 inches.
yeah, it's 1.5 inches for the IRC, but it's only 1 inch for the UPC. So
that's showing it from.
In ours, it's showing 1.25 inches, Larry.
Well,
Okay.
no, it's on that very first part of that diagram on the left. It says IRC minimum 1.25, UPC 1 inch.
yeah.
So what's the difference? What's the difference between the first
change.
piece and the second piece, Larry, where it says 1.5 inches?
Yeah, well, that's why I said there's been some changes since the code cycle when it went from 2012 to 2015.
Ours still shows the same thing yours does,
Oh, it does.
but then on that second piece of wood on the right, it shows it 1.5 inches, 1.5 inches past edge of hole. So there's two different ones on here. In the UPC, it shows 1 inch on the left one, and it shows 1.5 inches on the right side. Yeah, that drawing right there, it shows in our book the UPC minimum extension 1.5 inches.
Yeah, well, what they're talking about there, though, is that nail plate. See,
Okay.
that's the vertical. The first one is the offset from the pipe itself, horizontally.
Okay.
And the other one is the distance vertically that the nail plate is supposed to extend beyond the hole for the pipe.
Really?
That's why they've got two different holes. So right here, if you look slowly, see that? They're looking at,
Oh, with the metal plate, yeah.
yeah, with the metal plate, and they're showing the extension required above and below the pipe, 1.5 inches. So that's a vertical offset. The one
Oh,
on
wow,
the
okay.
left The one on the left, they're just showing you the horizontal distance from the face of the stud back to the pipe.
Oh, so the metal plate's got to extend up 1.5 inches past where the
Right.
actual hole is?
Right.
Okay.
Yeah, you can see
Because
the red arrow there.
They make those plates in a number of widths. And so occasionally the inspector is paying more attention to it than you may be using short plates because that's what you have. Hope you'll get away with it.
So why would it only be a 1 inch minimum?
That I don't know.
It says so right
That's
there.
weird. Electrical says 1 inch and a
Well, that's right.
quarter,
That's what it says, but that's one of the reasons that the plumbing and building people have never agreed. And the same with the plumbing and electrical people, they have slightly different requirements. And that's one of the reasons why we're kind of looking at this, but I'll have to look through my 8th edition because that's not one I spend a lot of time looking at anyway. So, but
wow.
table 11, that is there. So you see that's for maximum support intervals for different types of pipe material, horizontally and vertically. So table, I don't know if you have the same table numbers at table 11 in your book, your
The
version?
table 11 for the max support, yeah.
Yeah, okay. So the first column is the material. The second column is when the pipe is being run horizontal. And when it's horizontal, that means that it's not more than 45 degrees from horizontal. If it's more than 45 degrees from horizontal, it becomes vertical by definition. But vertically, the support requirements are somewhat different than they are for horizontal pipe. So CPVC or PEX. PEX is the kind of the new flexible water piping plastic. ABS and PVC, you have the same requirement. Horizontally, 4 feet. Cast iron with no hub fittings. And I haven't seen any cast iron with hub fittings on anything recent, so I'm not even sure they're making it anymore. And then copper tubing, you can see it depends on the size of the copper pipe. Less than or equal to 1.5 inches. You need to support copper tubing, 6 feet on center. If it's larger than 1.5 inches, then you can go up to 10-foot support, which makes some sense. Vertically, it's a little bit more lenient, but base and each floor at a maximum of 15 feet. So if you've got tall floors, you may have some intermediate supports on a vertical running pipe.
Yeah, and it helps with the water hammering effect.
Okay. Everybody know what water hammer is? Yay,
Yeah,
nay?
slamming water,
what is
slamming
it?
air into the pipes, yeah.
That's where you, particularly if you have high water pressure and you have a short throw valve, when you shut the water off quickly, it'll cause a pressure wave to travel back and forth through the pipes, and it'll make things rattle, and in some cases cause a failure in the pipe system. So
Shake your pipes loose.
but you know, your typical fixture that's produced today doesn't open and close rapidly. You have to turn and turn your faucet to get it all the way on. Well, there's a reason for that, and that's to keep you from having water hammer issues. You can get for angle stops, for example, which are little shut-off valves for the sink supply. They have short throw, and then they have others that screw in and out much more slowly than the short throw. But water hammer normally shouldn't be a problem in residential, because if your water pressure is too high, you're supposed to put a pressure regulator on.
Water hammer devices are for.
Yeah, or you can get Watts makes those little water hammer devices too.
That's why I like the angle stops that are screw in on the older houses that have too high a pressure. Those
Yeah.
little quarter turns have a tendency to slam the water.
Right. So anyway, for utility trenches, they got a little picture there, pipes in the trench. So you can put the water and the sewer in the same trench if the sewer pipe is approved.
And we don't have that picture.
Oh, you don't have that picture. Well, I'll give you a
I can
picture.
see it.
Oh,
I can see it on his, but we don't have it in our book.
yeah.
Oh, okay.
Yeah, I'll give you that picture then. Like I said, I need to flip through the 8. I thought I had the 8, but all I seem to be finding are.
I mean, our picture is like this, Larry.
Oh yeah, that's I've seen that one.
That's what we have in for 25. So it's just a little different.
Yeah, so at the bottom of that trench, what you can see is that the pipe is supposed to be continuously supported with, usually they put some sort of sand bedding in there.
Right?
There are requirements, so they're talking about for the backfill, fill in layers for first 12 inches with a smooth or granular material free of rocks or debris, and then that should be compacted, but pipes are to be fully supported on a smooth, even bed. Often what you see out in the field is you'll see a rock every 4 or 5 feet, or a piece of wood or stick, something. And that's not what the inspector really should be seeing. So where the piping comes up to the concrete, it's supposed to be wrapped in plastic, a bubble wrap or something. So if there's some movement in the building, some settlement of the slab, it doesn't pull on the pipe. And again, if you'll notice, everything under UPC, or most of that, is either out of Chapter 3, which is the general plumbing conditions, and Chapter 6, which deals with water piping. When I get down to gas, they're referring to Chapter 12. So that's where the gas piping is in the plumbing code. So didn't I tell you I was going to give you a yard piping document?
No?
No,
I thought I
not
did.
yet.
Let me see. Let's see if I can find it.
Yeah, our figure doesn't say anything about the first 12 inches either. It just says compacted backfill in 6-inch layers.
Okay.
Oh, no, it says it up there. It says until 12 inches of temp. No, it doesn't. It's different. Water service minimum 12 inches deep. Yeah, okay.
All right.
Gas
So,
piping. There we go.
I'm trying to find something.
Fog source is nice. Basics of fats, oils, and grease management. Nice. Oh,
How good is that? That's good.
that one. Fog.
So this is the one I will be sending you if I haven't sent it to you already.
Yeah, you haven't sent that yet.
Okay, so this was for electrical. This takes that information out of table 300-5 out of the electric code. So that's for electric line burial depths. And then on the back, I think we should have, or on the first page, these are the burial depths for plumbing.
Wow, it's nice.
So I will
Yeah, send that.
put
That'd
this
be
in a
good.
PDF and get
Yeah,
it to you.
definitely.
So you see gas, metal uncoated, that actually needs to be above ground. So water pipe, non-metal, at least 12 inches down. Metal, you can only use the metal piping if it's coated. So most of the gas these days is non-metal piping, and that needs to be at least 18 inches below grade for burial. So we don't have freezing problems here, so that's not a big issue.
So do they still denote white for water and black ABS for um, sewer? Excuse me.
Well, you wouldn't be running water in ABS at all.
Oh, PVC. I'm sorry.
PVC, yeah.
Okay.
So they have both PVC sewer pipe and they have PVC water pipe. But most sewer piping that's plastic in residential is ABS.
Mm-hmm.
And the reason we use the ABS is
Cheaper.
Cheaper.
it's cheaper. The answer is always it's cheaper. So, but, so if I haven't sent this to you, I will.
Yeah, that'd be good. Yeah, send that out. We want to save the changes. Absolutely. Oh,
Yeah. Well, I got rid of that, so we don't have it. Now, I did want to talk a little bit about fog, fats, oils, and grease.
I like it.
Okay. So I don't know, anybody here work with restaurants or deal with restaurants? Because that's a big problem. So
Yeah.
Yes.
putting things in the sewer, and this applies to your house too. They tell you you're not supposed to pour the fats, oils, and grease into the sink. You're supposed to,
Throw in the trash.
yeah, and drop them in the trash because it screws up the, clogs up the pipes, particularly when it gets cold. Usually if you're gonna have a clog in your plumbing system at home, that it happens either Thanksgiving or Christmas. And that's because that's when you're dumping all that grease into the system. And that's usually when the weather's cold. So, anyway,
Also, the toilet paper doesn't dissolve when it's with the grease.
Yes.
Like,
that,
it bunches up and makes it bigger.
yeah, that's also a problem because as it congeals, it's more likely to combine with other things and cause problems.
And people
So-
tend to use hot water to run it down the sink, and all that does is melt the fat, and then it congeals after it gets down in the pipes a little farther. So
Yeah, well, sometimes you can get it to unclog. You'll see the once in a while somebody will be pouring boiling water into it, but again, it depends on how far it has to go and how much it cools. POTW, that's a public-owned treatment works, so they're really talking about a sewer facility there. I think there's a couple pictures in here. Let's just take a quick look. I'll send this out to you.
oh, how cute! Yay, the polar bear.
Yeah. So there are two main categories of oils and grease. So that's the O&G. It's not original gangster. Non-polar. So industries, auto repair shops. So they're talking about petroleum-based oils and grease there. And then polar fog, food service, animal and vegetable-based oils and fats. And they, public health department and the sewering agency gets involved in this. But if you're doing a restaurant, normally you have to put in a grease interceptor or some sort of a gravity interceptor to take the fog out of the waste stream before it gets into the public sewer. So,
The dump out traps are for you.
Yeah, well, some of them actually, the newer ones, they call the service company. So many of the agencies require when you have a grease problem that you have an agreement with the company that does the maintenance on it, and they want to see it before they'll clear you for use.
And they
The-
do that with the duct, with the ventilation too. But yeah, more of
Yeah.
it goes into the water than it goes up into the air.
Right. So, anyway, you got yellow grease and brown grease. We don't care about that right now. That looks like a heart attack waiting to happen.
That's definitely an
Tastes so
artery
good.
burger.
Yeah.
Especially that burger is like 4 or 5 patties there.
Yeah, that's a small.
That's at Rutford's.
Well, yeah,
Yeah, I love that place.
they've got one in Tucson.
That looks good.
Oh yeah. So that's all that coffee creamer over there on the far right too. So that'll take care of it. Yeah, that's just a interceptor in the kitchen. So 3-compartment sink. Also, I'm not sure what's going on there because it looks like they've got some hoses down in the sink, and that's usually not permitted. But what happens, that's just some nice pictures showing how,
Oh, that's nice.
they've had the plumbing went bad. They've had to chop up the floor. So here in San Diego, the problem is if you get a clog in a public sewer, then you get a spill, city gets fined. And you have to have somebody come out and clean it up. So they have the big power jet sprays and Vector trucks, which is a big vacuum to try and get those things cleaned out. There's a bunch of penalties. We don't care about those. Now that looks like the bottom of a sewer manhole. And so at the very bottom of the manhole, there's kind of a half pipe channel in there to channelize the flow. In this particular case, you've got
Ooh.
sewer coming in from 2 different directions, combining and then going out of the manhole.
Yeah,
Just some nice pictures from inside of some sewer lines. So they TV them on a not infrequent basis these days. It's a fairly simple procedure because they can't afford to get dinged by the EPA or the Water Quality Control Board. That was $2 billion settlement in 2005, LA. So that was the EPA.
So the EPA gets that money?
Yep.
Wow.
So there's a gravity grease interceptor on the left and a hydromechanical grease interceptor on the right. The gravity interceptors can get pretty big. So I think we had one that was 10,000 gallons
Wow.
for, maybe it was for the honor camp outside their kitchen. The hydromechanical ones work a little bit differently, but generally they're quite a bit smaller. But they're not cheap. Either way, they're not cheap. Also, many times on the outside, you see on that gravity grease interceptor on the right, there's a little sample chamber there, so they can go in there and check the water quality coming out of the grease interceptor and see if it meets whatever the health department or the sewering agency requires. But the solids and stuff, the heavy stuff falls to the bottom. The fat, oil, and grease typically floats to the top. And that's why they have those pipes submerged, so that hopefully what's coming out is relatively clean water that doesn't have that sludge in it. So that would be a larger, normally in the ground, grease interceptor. Some of them actually sit on the floor just below the fixture. When I worked in the materials lab, we didn't have grease interceptors, but we had sand interceptors. We were washing dirt into the sinks all the time because it's part of the soil testing procedure. And you need to intercept that dirt before it gets into the sewage system. That's what they make biodiesel out of. So that's what that looks like, a little plastic bin there on just to the right of that sink is actually an above ground grease interceptor, a small one.
Mm-hmm.
So that's
So
where all
there-
that grease that gets collected into making the biodiesel?
Yep.
Wow.
And the newer ones, they have electronics in them. So when they need to be cleaned, they call whoever the cleaning service is and say, hey, we're about ready. Come out and take care of it. Anyway, so that's also covered in the Uniform Plumbing Code. We may get to that if you have questions on that, but I'll send this out to you because this is a pretty common problem. And in order to maintain them, they don't want the folks that are going to suck that grease out. If they're inside, they don't want it coming to the kitchen because they don't consider that to be a sanitary activity. So we get rid of that. We talked about that. Talked about that. I think we're good with that part of it. So any questions on fog?
Fog.
So
Oil, grease, what's the F?
F, fats,
Fat.
oils, and
Fats.
grease.
Fats,
That's
oil,
all
and
it
grease.
But it is a big deal, and I know restaurant is a common. I think when I did some work on Khan's Cave, was previously been a Chinese restaurant, and they didn't have an interceptor in there. And then when they switched over to the new restaurant, they had to put a 1,500 gallon interceptor out in the parking lot. So normally, if you're going to put
Wow.
a gravity interceptor, that should be outside in the parking lot so they don't have to go inside the building to work on them. No.
That must have cost.
Pardon?
That must have cost quite a bit.
Yeah, I think so. If you're looking for just the interceptors, if you go to the Zurn website, Z-U-R-N, or Shire also makes the interceptors. They have pricing on the interceptors based on size, and then they also, Shire has a nice online program where you can go in and do preliminary sizing and final sizing for grease interceptor.
Really?
Yep. So
Shire does or Zern?
Shire, I believe.
Okay, that's cool. I'm from the government and I'm here to help.
Yeah.
Okay.
Anyway, I'll show you something on Shire relatively soon. Maybe next week we can just walk you through that, because if you ever have to size it, it follows a procedure in the plumbing code. There is a procedure in the plumbing code. So there are two ways you can do it. One is you actually calculate the volume of each of the sinks or the fixtures that discharge into your grease interceptor. And they normally assume either a 1 minute or a 2 minute drain time, and you come up with so many gallons per minute of flow. That's one way. The other is they just count the fixture units, which we have in our book for some things. And depending on the fixture units, there's another chart in there that tells you how big of a grease interceptor you need. And if you're using a gravity interceptor, then 500 gallons is a small one, which
Yeah.
is not a small.
It's not a small tank, but
Okay, I'm gonna share with the class a picture of one of my units. This
Okay.
is what happened to your pipes. You see me? Oh, hold on,
Nope.
hold
I
on.
don't
No,
see-
we don't see.
oh, there you
Okay.
are.
I think you can spotlight yourself, can't you? Let me see.
You see that? There
Yeah,
you
it's
go.
great.
Yeah.
Oh man, that's bad.
That is a kitchen sink.
Wow.
Yep.
With our water pipes on one of the properties I manage, they 20 years ago, the biggest thing going was lining the inside of your pipes instead of
Yeah.
retrofitting.
Uh-huh,
That's-
yeah.
that's what all
I
of
had
my
that done.
Pipes look,
$100 a
the
pipe.
pipes look like. And so now when they and don't turn the on prop after shutting it off and they jam it open, that starts breaking loose and gets in all the fixtures. It's done. In the butt.
Yeah, In Situ Form does that. My shower plumbing looked a bit like that pipe. It had gotten to the point where I couldn't get a snake through it anymore. First, for a year or two, I was able to cut the tip off of the snake and run that through. But then it seized up entirely. So the next step was to get a jackhammer and jackhammer everything out.
That was your drain line, Kwong?
Yeah, that
Yeah,
That's even worse.
Yeah, well,
yeah, like 2.5 inch, like almost, yeah, it's a 2-inch sink
mhm.
hookup,
Oh my gosh.
kitchen sink. That's what happened.
Yeah,
And I'm
well,
like, and so I'll show you the fix too is that, let's see here. So you can see it's teed off into a cast iron. You see that?
yeah.
Yep.
Okay, so just imagine with that cast iron and it got all gunk up in there. So I literally go down in the middle of the pipe with a hacksaw blade, just a manual, just like a small 12 volts hacksaw, and increase and open that up to connect to until it connects. Luckily, the sewer was like right underneath it.
Wow.
So when I broke through on that, it was like Nirvana. But it
You
was
got cast
bad.
iron. All your drains are cast iron in the house?
Yeah,
All the
generally-
major ones, yeah. So what I had to
How
do,
old is the house?
1953.
As old as
Wow.
Larry's house.
yeah, generally
So,
up
all
until
of, so so I have to cut out all of that bodies
Yeah.
because the only
Wow.
way to reconnect it. You see that now? Yeah, there you go.
Yeah.
until the early 60s, almost all the plumbing was cast iron. They didn't start using plastic until I think the mid 60s or so.
Oh, yeah.
Wow.
And if you have the old cast iron, it has a definite lifespan on it. So typically 40 to 60 years is considered to be the lifespan on cast iron, and then you start having problems.
Or was that asbestos pipe too that they used to use a
And
lot?
so, yeah,
So nasty.
Yeah, that's
Here's
uh,
our
trick
fix.
pipe.
My plumber did this. You see this? There you go. So go below that T
Yeah,
or so we put in 2 of those, and then we put a Santee on the back side to hook up to the sink.
yeah,
Larry, can you zoom in on Kong's stuff? Because I can't see I see what he's showing us.
let me
Okay.
see what I can do
I
here.
can see it.
Yeah, you see that?
Good for you, Rick. I
Yeah,
can't.
just
Sorry, Marianne.
Too dark.
Marianne, if you click on the 3 dots on his picture, it's gonna tell you you can pin his chat.
Yeah,
Pin
what,
video?
His-
Kong?
yes.
Okay, nice. Yeah, thank you.
Oh,
Yeah, if you'll email me a couple of those pictures, then I'll send them out in an email.
sure. Okay. Deal.
Probably the best thing. So,
All right. So
let me just show one more thing, and looks like we're starting to get some of our time. Oh yeah, there we are. So,
There you
back
go.
to this. So you should be seeing the plumbing table again.
Yep, I can see it.
Okay.
The DFUs and traps.
Yeah, DFU. So that's a drainage fixture unit. But you have to be very careful because some people think a DFU is something else entirely. Something quite dumb.
Whatever. What do you mean?
What I mean, yeah. So again, this is strictly residential. I'll be sending you out a table from the California Plumbing Code that has a more complete table that includes commercial things. And again, we're only using the Uniform Plumbing Code, the IRC. If you look at this, so this is the trap and trap arm sizes.
And we don't have that code exactly in here. Oh yeah, no, here's the bidet
Yeah, it'll be in there somewhere.
figure. It's table 14 now. Okay.
Yeah, I'll make sure I track down the 8th edition. I hope I didn't leave it at school, so.
In the 8th edition, it's table 14.
Okay, so if you look at table 14, if you have the 8th edition, if you have another one, an earlier one, it'll be table 12. But if you look at that, it lists the fixture on the far left, right here.
Yep.
Maybe, yeah. So if we look at
Yeah, it
that
does.
laundry tub, then the minimum trap size is 1.5 inches. The drainage fixture units, which we will need in order to size piping later, but we'll go through an exercise, is 2 drainage fixture units. And this is where things get a little dicey. You will notice that in the IRC, it says the trap arm can be 6 feet
6
long.
feet. Wow.
However, if you look at the Uniform Plumbing Code, it says
3 feet 6 inches.
3 feet 6 inches. And
Wow. 6 foot trap arm. That's huge.
yeah, well, that's why I say the
Crazy.
International Plumbing Code or International Residential Code is much more generous. And you should have this picture in your book too. So for those of you who aren't plumbers or who pay no attention to the plumbing,
Yeah.
this is the trap, and the trap arm
Wow.
is from the trap over to, in this case, the sanitary teeth. And so that's that trap arm length that they're talking about in that table.
6 foot's gigantic. Jesus.
Yeah, that weir, that's the overflow. That's where the water flows out of the trap and into the drain. And you'll notice on that trap arm that it slopes. It's supposed to slope 1/4 inch per foot. However, it's not unusual for them to be flat or in some cases slightly reversed.
yeah.
As long as the water gets higher than the outlet, it'll still flow, but technically you're supposed to have 1/4 inch per foot there.
It just makes it harder for the service person to come in if it's sloped the other way.
Right, right.
You
And
get wet.
so this distance here, from here, the weir, horizontally straight across, that's the trap seal. That's filled with water. And so that what that does is that bit of water keeps the sewer gases from coming up into the building. That's why sometimes they tell you if you're going to be gone for a long period of time, if you're going on vacation, have somebody come over and pour some water in your sink, for example. That's because that trap seal will evaporate over time. And then you may get gas, sewer gas inside the house or building.
Which is
you have a
methane,
floor-
and you don't want that.
Yeah, if you have a floor drain, which is usually an emergency backup in case you have a sink overflow in a commercial establishment or in a public restroom where the sink or the toilet may overflow, then usually you're required to have what's called a trap primer. And so that senses when that trap is gone, and then it will spritz water into the trap to maintain the trap seal.
Trap primer. I want one of those.
Yeah, well, you may have to put one in some cases. So I put, when I put a laundry in, the last time I put in a trap primer because I put a drain in the bottom of the laundry pan where the washing machine sits, because sooner or later, the washing machine is gonna have problems.
It's gonna leak.
Gonna have problems. And I wanted the water to go away, but I also had the problem with it. Unless I periodically pour water in there, you're going to have problems with the trap seal evaporating. So I put in a trap seal primer. And then if you put in a trap seal primer, you need to have an accessible box or something so you can get in and service it or replace it if you need to.
Wow.
So
That's thinking ahead, Larry.
anyway,
That's a good one.
Yeah, I think, what's the time here?
7:40.
140.
I think we will stop things. I'll stop recording at this point.